Hello viewers, this is Workday Ronald taking you through the tutorial on A-Level Physics, and today we're going to look at the solutions to A-Level Physics Paper 1 for UNEB 2019, and particularly we are going to concentrate on question 2. So where necessary, the following constants will be used. Now this is the very question I left in the previous video, and I believe that by now you have already tried the solutions to this question and you are eagerly waiting to mark yourself. So we are going to go through these solutions and see how marks can be awarded such that you can mark yourself and also check your progress. Now we are going to begin with question 2 part A. Part A said, define moment over force and give its SI unit, and they give it 2 marks. So let's see how those 2 marks could be got. So for the part of defining, we can say that moment over force about an axis is the product of a force and its perpendicular distance from the axis of rotation to the line of action of the force. So when you do that, that will be a correct definition. Alternatively, you can say that moment over force is the product of the force and the perpendicular distance of its line of action from the pivot. So pivot is the same as the axis of rotation. Any of the 2 is correct, but they also ask for the SI unit. So shall come and say that the SI unit is Newton meter. Now I think that's what they wanted in part A. Now let's see how marks can be awarded. So 1 mark would be for the definition. So any one of these 2 definitions will be correct. You don't write both, only choose one which is easier for you to remember and write that one. Then the next will be for the SI unit. Now this SI unit, you can choose to write it in words like this, or you choose to write this. So any of the 2 is okay. So basically when you do that, you'll get yourself the other 1 mark. Now we shall go to part B. Part B says, explain briefly how to locate the center of gravity of an irregular sheet of cardboard, and they give it 4 marks. So first of all, we shall say 3 holes A, B and C are made at well-spaced intervals round the edges of a cardboard sheet. So what does that mean? It means that this is an irregular cardboard sheet. Irregular meaning it has no it doesn't have a specific shape, and you make 3 holes. This is hole A, this is hole B, and this is hole C. So basically that's what this line means. Now after doing that, what next? A stout pin or nail is then put through one of the holes, so let's say hole A, and clamped firmly on a retort stand so that the lamina can swing freely on it. Now this lamina is the cardboard sheet. What does that mean? It means that this is the clamp retort stand and this is the pin. Now this pin or nail is passed through one hole which was made on the cardboard sheet, which is irregular, and you leave it to swing freely. Then after doing that, what happens? A plumb line, which is a thread with a weight, is also suspended from the same point. Know that word, same point. So what does that mean? It means that now this is the plumb line. It has a weight and a thread, so you suspend it from that same point where the hole is. Now when the cardboard sheet and the plumb line come to rest, remember they suspended free, so they will swing until they will come to rest. So when they come to rest, a line is drawn using a pencil on the cardboard sheet, tracing the plumb line thread. So what does that mean? For example, when it comes to rest, this will be the thread of this plumb line. So what you do, you draw a line through tracing this line of this thread. Then after that, the above procedure is repeated repeated for the rest of the holes, that is hole A, B and hole A, and the point of intersection of the pencil lines, point G, will be the center of gravity of the cardboard sheet. So you repeat the same procedure. In other words, suspend the lamina from using this hole B, and when you repeat the same procedure, you'll be able to trace this pencil line, and when you suspend it from hole C, you'll be able to trace this pencil line. Now the center of intersection, or the point of intersection, which is G, will be the center of gravity of that irregular cardboard sheet. So basically that's what they wanted in this experiment, and now let's see how marks can be awarded. So the first mark will be for making holes or drilling holes at well spaced intervals around the cardboard sheet, and next mark will be for suspending the lamina through one hole, and another mark is for you to allow it to swing freely. So you suspend it so that it swings freely. Another mark is for you to put the plumb line through that same point, and then another one will be for you to allow it to allow both of them to come to rest. Then another mark will be for you to draw a pencil line tracing the line of this thread of the plumb line. Another one will be for you to repeat the procedure for other holes, that is hole B and hole C. And lastly, the point of intersection, for you to locate the point of intersection, which is the center of gravity which they want, you'll be able to get yourself another half a mark. So basically that's how the 4 marks could be got in this part. Now we shall go to part C. Part C says that state the conditions necessary for equilibrium of a rigid body, know that word, rigid body, under the action of a system of forces, and they give it 2 marks. So we shall come and set. So the first one says that the algebraic sum of all forces on a rigid body must be 0. In other words, the resultant force on a body must be 0. And the second condition says the algebraic sum of the moments of all the forces about any arbitrary point must be 0. What does that mean? It means that the sum of anti-clockwise moments about a point must be equal to the sum of clockwise moments about the same point. So basically those are the 2 conditions which they wanted. Now let's see how marks can be awarded. So first mark will be for the first condition. So you can either write this or you write this, but any of the 2 will be okay. Another mark will be for the second condition. So you can either write that or you write this. So that's how you can get your 2 marks. Now we shall go to part D. Part D says a wheel of radius 0.5 meters rests on a level surface at point C and makes contact with edge E. This is edge E, so this is the wheel. It makes contact with edge E of the block of height 0.2 meters as shown in figure 2. So this is a block of height 0.2 meters, and this is the wheel of radius 0.5 meters, and there is a force F which is applied. So they say a force F is applied horizontally through the axle, meaning this force is passing through the center X, which is the axle of the wheel at X, to just move, know that word, just move the wheel over the block. If the weight of the wheel is 180 newtons, find Roman 1 the force exerted at point E, and Roman 2 the force F. So the force exerted at point E, here there will be a force, and also they want the value of this force F. So basically let's start with Roman 1. Roman 1, the first thing to do is to draw a diagram to show those forces. So this is the force exerted at point E, and this will be the weight of the block. They said the weight was 180 newtons, and this will be the force, horizontal force applied on this wheel. So what they want the value of this force exerted at point E, that is Roman 1, and Roman 2, they want the value of this horizontal force applied on the wheel. Now let's see how we can get that. So the first thing to do, for you to get this force, you have to first know this east direction. So what we are going to do, we shall first extract out this right angle triangle XYE, and for that triangle we shall realize that XY is equal to 0.5 minus 0.2. Remember, from here to here it is 0.5, which is this, and from here to here it is 0.2, which is that. Therefore the remaining part will be this 0.5 minus 0.2 to come up with 0.3. so we have got our XY as 0.3, but we also know that this distance from here, XE, is equal to the radius of this wheel, which is 0.5. What does that mean? It means that for this angle we have got the opposite, which is 0.3, and the hypotenuse, which is 0.5, and that means that sine theta will be equal to 0.3 over 0.5, and when you use the calculator we shall come up with our angle of theta as 38.8699 degrees. So now that we have got the angle, we can now resolve. So when we resolve vertically, we shall come up with r sine theta equal to 180. So vertically, this force, when you resolve it vertically, it will be r sine theta, because this angle is lying on the horizontal, meaning that the vertical component will have sine, and this is entirely vertical. That's why you put here 180. And when I substitute, I know that sine theta is equal to 0.3 over 0.5, so I'll come and substitute here, and when I make r the subject, I'll come up with my r as 300 newtons. So basically that's what they wanted in Roman 1. Now for Roman 2, they want the value of force F. So for you to get the value of force F, we are going to resolve horizontally. When I resolve horizontally, I'll come up with this component of this force being r cos theta, and also this being equal to F, which is entirely horizontal. So when I do that, I'll come up with my F being equal to r cos theta. But I know that theta is equal to 38.8699, so I'll come and substitute that for r, which is 300, and for theta, which is 38.8699 degrees. When I use the calculator, I'll come up with my value of F being equal to 240.0 newtons. So basically that's what they wanted in part D. Now let's see how marks can be awarded. So the first mark is for you to locate this force which acts at point E, and also another mark is for you to locate the weight of the wheel. The another half a mark will be for you to attempt to find the value of theta, and also the other half a mark will be for the value of theta. The another one will be for resolving vertically to come up with this, and the another one will be for substituting. Remember, sine theta is equal to this 0.3 over 0.5. So when I substitute, I'll come up with this other half, and then using a calculator, I'll come up with this magnitude will be a half a mark, and the unit will be another half a mark. So that's where this complete mark, full mark, can come from. Half a mark for the magnitude, correct magnitude, and half a mark for the correct unit. So with that, you'll be able to get yourself 4 marks. Now for Roman 2, the first half a mark is for you to resolve horizontally, another half a mark is for you to substitute for r and for theta, and a full mark for the final answer with correct SI unit. So half a mark is for the correct magnitude, another half a mark is for the correct unit. So with that, you'll be able to get yourself the 2 marks which they wanted in that question. Now we shall go to part E. part E says state the laws of solid friction and explain each of them. So they give it 6 marks. Now the laws are 3, meaning that each law will be carrying 2 marks. So what you are going to do here, let's start with the first law. First law states that the frictional force acts parallel to the surfaces in contact and in a direction so as to oppose their relative motion. So that is the first law. Now let's see its explanation. So the explanation says, for 2 surfaces in contact, the actual area of contact is very small. And what does that mean? It means that the pressure is very high at the points of contact. And because the pressure is very high, projections are welded at these points, and therefore a force that opposes motion is obtained. Why? Because of those projections at the welded joints. So basically that explains the first law. But also some students can state the first law as that the frictional force opposes relative motion between 2 surfaces in contact. So that is also okay. And the explanation for that, in case you study this law, the explanation will be that with 2 surfaces in contact, many projections which adhere to each other exist, and this opposes motion between the 2 surfaces. So any of the 2, you can choose to write this or you choose to write this for that first law. It is also still okay. Now before we go to the next slide, let's see how marks can be awarded. So the 2 marks for the first law, the first full mark will be for the used to state, and another mark will be for you to explain. So for you to explain, you'll be able to get your 1 other mark. So basically that's how the 2 marks can come from. So if you wrote this, that is how the 2 marks can come. And if you wrote this, 1 mark will be for stating, another mark will be for explanation. So basically that's how the 2 marks can come, and you consider any one. So you can choose to write this or you choose to write this, but not both. Remember that you have to be precise and actually the points. So even if you know both of them, you have to choose one which is simpler for you. Remember, we need to pass by saving time. Now shall go to the continuation. We are still continuing. Remember, there are 3 laws. You have already explained the first law. Now what we are going to do, we are going to explain the second law. So the second law states that frictional force depends on the nature of the surfaces in contact, but independent. It depends on the nature of surfaces in contact, but independent on their area of contact, provided normal reaction remains constant. Now most students forget this condition. This condition is very, very vital. Normal reaction must remain constant. So when you write that, the explanation can be that when the area of contact of the surfaces is reduced, the number of contact points approximately remains the same, hence the resisting force is not affected. So that's how you can explain that. But also you can also state the second law in the following way. So you can say that it states that the frictional force between 2 surfaces in contact is independent of the area of contact, provided normal reaction remains the same. I think you can see that this last condition has to exist in the second law. And if you wrote this, the explanation would be that the actual area of contact is the sum of the area of tiny projections that adhere, know that word, adhere to each other, which is nearly independent of surface area. So any of the two is okay. So let's see how marks can be awarded. So first mark is for the correct law, correctly stating the law. Another mark is for you to explain it. That is if you wrote this, and if you wrote this, the full mark will be for stating, and also the other mark will be for explanation. So any of the two will be able to earn yourself 2 marks. Remember, you have to write only one, not both, even though you know both of them. So we have explained the second law. Now we are going to the third law. So the third law is a bit lengthy, but you have to write it anyway. So it says that when the surfaces are at rest, limiting friction of force is directly proportional to the normal reaction. But when they are in relative motion, kinetic friction is directly proportional to normal reaction and independent on their relative velocity. So we talk about 2 kinds of friction. Limiting friction is the maximum friction for a body when at the point of sliding, and kinetic friction is the friction for a body in motion. So we have to talk about both of them, limiting friction and kinetic friction. That's why it's a bit lengthy, but you have to write it anyway. Now let's go to the explanation. So the explanation, we shall say, an increase in the weight of the upper surface, that is increasing normal reaction, increases the pressure at the welded joints. This leads to a greater degree of interlocking and hence a greater force required to cause motion. So that is one of the explanations, but I can also explain it in the following way. So in this case, we shall say that normal force determines the actual area of contact. When the force increases, the interlocking of the projection is stronger and hence frictional force increases. So any of the 2 explanations will be okay. Now let's see how marks can be awarded. A full mark for the stating the law, and another mark is for you to explain. So if you wrote this explanation, that will be how you can get the 1 mark. If you wrote this, the 1 mark will be got from in that way. So basically that's what they wanted, and with that you can be able to earn yourself 2 marks for correct law with any 1 explanation. So remember, I've seen 2 explanations, but you choose 1. Even though you know both, you have to write only and only 1. Remember our slogan that excel by saving time. So I believe you have marked yourself and checked your progress. So that's how you could get the 20 marks in this question. What I'm going to do, I'm going to leave you with another essay question, and that is question 3 for Physics 1 paper 1 of UNEB 2019 for you to try out and check your progress further. So that has been our lesson for today. Thank you for watching, and be reminded that the solution to this assignment I've left will be available in my next video. So if you have not yet subscribed, please click the subscribe button below so that you'll be receiving updates when I release the video with the solutions. Otherwise, thank you for watching, and if you know of any student who is not yet on this platform, please use that share button to share the link of this video with as many students as possible via social media like WhatsApp and Facebook. Otherwise, thank you for watching, and hope to see you in the next video while making assessment for what you have answered. Thank you.